Hello ladies and gentlemen, in this video we're going to bring it all together and we're going to make something called the Geneva mechanism. This is a Geneva mechanism. It's one of the basic indexing mechanisms. Let's just explain. I guess let me just give you some terminology just so it makes sense what it is. This is the drive wheel and this is the driven wheel. This thing has this little pin coming out of it and it goes into the slot and moves it, and as it moves it there's a disc attached to this driven wheel that comes in contact with the radius that's cut into the wheel and keeps it from moving around too much, and then the process repeats, and that's why it's called an indexing mechanism, because every 60 degrees is going to be moved by one revolution. So you have some price you have precise control of how much movement is occurring per rotation. So if you have a motor here and it's moving around, 60 degrees moving um, every every rotation, and you have some industrial applications like putting this on a conveyor belt or something. Um, but yeah, and I'm not gonna go through how to calculate the dimensions for these things. I already have those calculated on a paper in front of me. Uh, and if you don't want to do it, it's fine. I'm gonna just make the thing and you can just follow along, but I definitely recommend just go to this website. It's called newgoatland.com. It's a fantastic website. I'm gonna post this link on the description, and hopefully these website people uh, they don't get angry or something. I'm using these equations, and these are very basic equations, as you can see, just division, addition, a little bit of trigonometry. But if you're engineering students, this should be a joke to you. If you're not, this should still be a joke to you, because this is not difficult. Um, so all the dimensions and all these letters are labeled as dimensions on these pictures. So you got pictures with proper dimensions labeled. I don't know what else you need. But I'll explain what these equations are. These four are the equations, I guess. No, not the equations. These are the parameters that you decide. So you're going to come up with a drive crank radius. You're going to say if you want something to be 5 inches, 6 inches, it's up to you. Number of slots that you want, those are these slots right here. This wheel has 6. The one I'm going to make, it's going to have 4. Pin diameter is the pin in this Geneva wheel, the green one, this thing that's going into the slots, the diameter of that pin. And the tolerance is supposed to be something along the lines of 0.01 or 0.001. It's don't make it to be 2 inches, because that makes no sense. Uh, and just read these labels. Center to center distance is the distance between this point and this point. And just go through it and look what each dimension represents, because it's kind of not required, but it's good to know what these dimensions are doing, and then you can see exactly how this gear or how this mechanism comes together, and then you can kind of appreciate the first person to come up with and how they did it and why it's kind of amazing. So let's begin. We're gonna make this in Creo, and we're gonna use a bunch of tools that we learned in the previous videos, and we're gonna bring it all together. Let's make a sketch. Let me just change the grid to static. Is the grid on? The grid is not on. Now the grid is on. I'm gonna make a circle. I already have the dimensions calculated, by the way. I have the dimensions turned off as well, apparently. Okay, there we go. So my dimensions are 8 for the diameter. I said 8 and I typed in 4 because I'm just that good. Okay, so that's that. I'm gonna extrude that out to a random thickness that I decide. It's 0.25. It looks a little thin, but it's fine. Okay, so this is like a canvas right now, and what we're making right now is the red side. That's what we're making. Um, so let me just sketch on the surface. I click sketch. I select the surface I want to sketch. Go back in. Now I'm gonna make the slot. So you see these slots that green pin is going into? That's what I'm gonna make now. And let's see, the distance for that is, first I'm gonna go in construction mode and get a point where I can start. So let's see, actually this is, I think I was gonna save this for the advanced stuff, but okay. So I want to make a circle, or I want to make anything on a piece of geometry that already exists. There's a way to do that where you can make references, and you can have these blue dotted lines as references. So if I select a circle, let's say, and I say this is my reference now, as you can see right there, I don't know if you can, but if you do this yourself in Creo, you'll see that your cursor or whatever tool you're using is going to tend to stick to that reference if you're close to it. So it's easy for me to make a circle at the reference I'm selecting, and that's the whole point of the reference, that you can have some point as almost active, and that's going to serve as a point that you can kind of snap to with your cursor, and that's what I'm doing. So I'm going to try to make a line, and I'm going to try to get somewhere around this point to have my slot. So let's make that slot, and first I'm going to select this as a reference. And the way to do that is you can click references and select your references and do whatever, but I like to do it a little differently. I hold down Alt and then I click wherever I want it to be my reference. So see right here how it's activating right now. I have Alt holding and I click it. Now it's my reference. So if I make a circle, alright, the order matters too. So you're gonna have to select the tool that you want to use first, have that activated, and then select the reference by holding that Alt and clicking. I'm gonna make a construction line. I'm gonna hold down Alt and click. The center plane is already my reference, so I'm gonna start here. I'm gonna click and drag, and we have a dimension here. My size that I came up with was 2.34 315. Okay, so that's my construction line, and I'm gonna make a circle at that point now. And that's I guess a good way to demonstrate the use of construction lines, because to get to that point it will be kind of tricky, and this way I can control it however I want. See, now I have the circle here 1, and now I can just control where it is by just saying this 3, and I can say 1, and it moves wherever I want it to, and I just have to change one dimension, and that's why it's kind of nice to use construction. But let's go back to that 2.34315. Okay. Oh wait, no. Let's go back in the sketch. Right click, edit definition. That's not the slot. Let's see. So now we're gonna make a line that goes tangent to this. I can just do this. Make a rectangle. Not a rectangle. What am I doing? Okay, so we're gonna make a line that's going straight across. You can kind of go over right here, and if you're not sure that this is tangent, you can actually select certain things or lines and circles and say under these constraints that make them tangent, and then it's gonna put that constraint on there, and you can display that constraint now by going here, and see right here it says T tangent, and it is, and that's that. So now we're almost there, but we need to close this loop out, because if you remember, we need to close geometries to have them complete, and when I hit escape, it's not highlighting the geometry to say that okay, now it's good, so we need to make it good. So we're going to use the arc tool. I'm going to use center ends. As you remember, I like center ends, and I'm going to go from there to there. Okay, almost done. Now we're going to delete this extra lines here, and we're going to delete this inside lines of the circle, and now when I hit escape, it should kind of brighten it up. It didn't. Whoa, what's happening here? Okay, see, okay, so this is good to kind of showcase. You're gonna have these tiny little straggler lines. I don't know why they exist, they just do. And if you ever run into a problem like that where you're trying to extrude 2D geometry and it's not, chances are you have leftover small little piece of line somewhere. Find it and see, now it should light up like this, And now I'm gonna extrude that in. I'm gonna hit OK, and I'm gonna say extrude it in on the other side. And it's gonna, to remove material, you just select this, remove material. Whoa, something's wrong here. Let's go back to our sketch, because it should be going all the way up, and it's not. So let's edit that sketch. I'm gonna delete this arc, and instead of making an arc, I'm gonna, I think, make a circle. But let me just try the arc again. Oh, I know what happened. The arc was supposed to be from the center point of the entire thing, and I made it from the center point of the slot circle. That's what happened. Silly me. Okay, I think that's good now. Let's try it though. I think I have a feeling it's gonna go bad. Is it gonna go bad? Yeah, it's gonna go bad. Let me just remake the entire 2D thing instead. Let's get rid of this line, let's get rid of that line, and let's get rid of that line. This little area right there is fine the way it is. We already have our tangent set up. Oh, look at that. So the way I guess it's doing it now is I had the outer edge of the circle selected as reference, and it's going up to that point now, and it should be okay. And now we're gonna make an arc again. Hopefully we do it right this time. Okay, that's that. We're gonna extrude out to the other side. There we go. It's doing it right now. Actually, let me go back to the extrude. See how it's extruding outwards? I don't know if I went over this already, but I'll go over again. Right here, click and drag, and select the one that says up until the next surface. I think I already went over the double-sided one as well, and there's a bunch more, but that's what we need right now. So we have our slot. We go back to it. What we need now is this little curve that's cut into the thing that stops the disc from wobbling around once the drive radius, I mean the drive crank, goes around. So let's make that. And the way to make that is we have to kind of think how this mechanism works. If we look at it, this disc right here, it's kind of made, or I should say, it's dimensioned from the center of the drive. And we're making the wheel. So if we want to cut this radius, we're going to have to make it from a perspective of the drive. So we're going to have to figure out where this point is. Well, we're going to have to figure out where this point is, and from that point we're going to have to make a circle and cut into the wheel. And that's what we're going to do. And as I said, I want 4 slots. I don't know if I said that, but I want 4 slots. And we're going to sketch into this. And so if we're going to have 4 slots, they're going to be 90 degrees apart, right? And one's going to be here, one's going to be in horizontal both sides and vertical both sides. So, 1, 2, 3, 4. And same way for the disc stop radius, 1, 2, 3, 4. So I'm just going to make one here, and you kind of already guessed probably what I'm going to do afterwards. I'm just going to pattern those cuts across, but we'll get to that. So let's sketch. We're going to go into a construction mode again, and I'm going to make a line from the center going across to the first quadrant. You should remember what that is, geometry, first quadrant. And you probably cannot see this construction line. It's very, very light colored. But now I'm going to try to control the dimensions here. It already gave me some dimensions and some angles, but if you go up top here at the dimensions where it says normal, click that, select the line, and then middle mouse button click right there. You can control the size. And my calculated size for center to center distance is 5.65685. Yours might be different, it's fine. And it says 5.66. If you double click, it says what I told it to just actually be, and don't worry about that, it's gonna just show you a random value. And to select the angle, you have that tool activated again. Click the line, then hold down control and click another reference line, middle mouse button click, and then you can change the angle. And for us it's 45, because if we're changing 90 degrees, this is the center point. The center point of a 90 degree iteration is going to be the 45 degree mark, right? It's going to make sense once I actually make the whole thing, don't worry. So again, to change the dimensions of anything, not necessarily just construction geometry, you click on normal, select the line, middle mouse button click, and if you want to change the dimensions of something in reference to another thing, you activate this tool again, hold down control, select the two things you want to control, and then middle mouse button click. And then you can control almost anything and be precise with your creations. And now I'm going to get out of construction mode because I have that point in space that I want, and from that I can make a circle now. And my radius for the stop disk radius that I calculated was 2.49, and Creo is asking me to put in a diameter, so I'll just multiply that by 2, 4.98, and that's it. And we'll just to properly extrude this out, I'm going to make another circle, not a circle, an arc from this point, and I'm going to select the reference again, hold down Alt, select the edge I want to select as a reference, and make the arc right there, one point to the other, and then I'm going to delete the extra bits here, and hopefully, yep, it's good to go, and that's okay. And now I'm going to extrude this on the other side as well. I'm going to say go on the other side. I could have just clicked this arrow and it would change directions, and I'm going to say remove material, and see it did that pretty nicely. And then just to be efficient, or I should say just to be official, I'm going to say go up until the next surface, and that's it. So now we have what looks like a quarter of the disk right here, so one part of it, and we're going to pattern this across, and we're going to make the whole thing. Let me hold down control, and now we're going to pattern this in a way that I've never shown you before. I've shown how to do direction, I've shown how to do curves and things. Now this pattern is called an axis, based on an axis. Sorry. So I'm going to say show me the axes, and we have a center axis right here, and I'm going to pattern these things. I'm going to go into the pattern command, I'm going to select what I want to pattern, and it's going to be a geometric pattern, and I'm going to select axes. Also, actually I should go over that. If you select certain things and now the pattern command isn't highlighted anymore, don't be scared, just click down on the drop down menu and click geometric pattern. All that means is now you're trying to pattern some things that are not going to be patterned in the standard dimension way. So we go into axes right here, and we select the axes that we want to pattern across, and it might be small, just zoom in and click on it, see right here, and I already have everything put in place, 4 and 90 degrees apart, and that's it. So right there we have our Geneva wheel made, and it looks pretty nice. I think it looks nice, at least. That's it. And of course, any wheel, we're gonna have to have a center hole punched in, and we're gonna punch a hole in the center. Let's go here. This is where, you know, you would have your motor plugged in. Well, not really. You would have just a shaft plugged in that will allow the whole thing to rotate. Let's make that diameter to be 0.475. Move material. Okay, so I'm gonna go get a drink of water because my throat is drying up right now for some reason, and then we'll make the Geneva drive in the next video, and then we'll bring it together in next series of assemblies. See you in the next video.